Hi, welcome to the double displacement reaction video. This one is for acid-base chemistry. So just a quick reminder, what you're expected to do with these problems is predict the products and balance the equation, then write a complete ionic equation and a net ionic equation. So acid-base double displacement reactions involve an acid. We recognize an acid as having either an H in the front or a Cu group, COOH, in the back. And our bases that we're dealing with are metal hydroxide bases. Hydroxide is a polyatomic with the formula OH minus, okay? So with that being said, if I can find the hydroxide, where did it go? It's on this thing somewhere. All right, so with that being said, what we are going to do is we are going to look at how to, here we go. We're going to look at how to write the acid-base reactions, predict the products, etc. The products are always going to be a salt or an ionic compound that uses the metal from the base, and the non-metal part or the non-H part, we call that the conjugate base of the acid. So for this example, the H part of the acid goes with the OH to make water. That's how you make water, HOH. And then the metal of the base goes with the X, or the anion, or the conjugate base part of the acid makes the ionic compound MX. All right, so let's take a look at our reaction here. Here we have H2SO4 and barium hydroxide. So sulfuric acid and barium hydroxide. So remember that the H from the acid is going to go with the base, and that's going to form HOH. Now, a very common error is because people see, oh, there's two hydrogens there and two OHs. They tend to write this. All right, they move the subscripts over. Just like you did with the double displacement reaction, do not move the subscripts over. Do not do it, okay? You use the subscripts are determined by the molecule itself. So these hydrogens, by the way, they're acidic hydrogens. They have a charge, an oxidation number of +1, and hydroxide has a charge of -1. So you only need one H plus and one OH minus to have a balanced formula, okay? So that's why it's just HOH. These subscripts over here will get taken care of when we balance the equation. They'll probably pop up as coefficients of the molecule. All right, so now with that being said, we're now going to also form our ionic compound, our salt. So barium and sulfate get together and make barium sulfate. And as you did before, in order to figure out if this is the correct formula for barium sulfate, all right, you need to look at the charges. So barium has a +2 charge, sulfate has a -2 charge, so you need one of each of these. This is the correct formula. You can't just look here and say, oh, there's no subscripts here, and there's no subscripts for the sulfate here, so that's the formula. No, you have to figure it out from the charges. All right, now that we've done that, we are now going to go ahead and balance this. So on this side, we have two hydrogens, we have one sulfate, we have one barium, and we have two, using the two outside the parentheses there, two hydroxides. Now here we have, some people look at this, especially if you write it as H2O, may think, oh, we have two hydrogens. Remember, this is sort of split into two pieces, the H plus from the acid and the OH minus from the base. So we technically have one H and one OH, just the way that we're doing this. Remember, this strategy in balancing is you divide things out into their cations and anions. We're not listing all the individual elements or all the individual atoms. You could, of course, do that, but when you do that, it just makes more work for you. So it's better to split them up into the pieces that switch, the cations and anions. All right, we've got one sulfate and one barium on this side. So I look at this and I say everything's balanced except for the H and the OH. Okay, I have two H and OHs on the reactant side and just one on the product side. So I just need to simply put a coefficient of 2. So remember how I said that those subscripts before, you may have thought, oh, I'm going to put them in the molecule and boom, boom. No, remember, they probably will appear as a coefficient if you need to balance it. All right, to balance the number of atoms. Okay, so with that being said, we have determined our products, we've balanced our equation. Now the next couple of things we need to do is write the complete ionic equation. Now before we do that, we are going to first go ahead and label things. So all of the acids, they're always going to have an aqueous symbol, but there's something that you need to know about acids when we do the complete ionic equation. Just because for acids they have an aqueous symbol, we can't just split it up based on that. And that's because you'll notice that acids are not ionic compounds. Like what we did before with precipitate reaction, barium hydroxide, barium sulfate, those are ionic compounds because they have a metal and non-metal. So if they're aqueous, then you can split them apart into ions. But acids are covalent molecules. These have all non-metal atoms. So just because they're aqueous doesn't mean we can split them apart into ions. We'll see when we can split the acids apart and when we can't. Okay, so barium hydroxide is next. If you look on the chart here, barium hydroxide is aqueous. So we can do AQ for that. Water, H2O. What is water? It's a liquid. So for water, you're always going to label it as a liquid at room temperature. And then finally for barium sulfate, we look, and it's a solid, okay? Now for most of these, I'll try to make it simple and not have you worry about the product side, the salt ionic compound on the product side or on the reactant side so much. So the ones you'll have on the exam will be aqueous. But how do you handle something like this in general? Like what do you do? So the next step down is to write a complete ionic equation. And the rules for here for acid base are just a little different. The idea is you can ionize aqueous ionic compounds, right? So the base and the salt that's formed, so the base and the salt, if it has aqueous, we can break it into ions, break it apart, just like we did before. But for the acids, you can only ionize them if they are a strong acid, if it's one of these. If it's not on this list, you can't break it apart into ions. And any other phase, like liquid or gas, you can't break those apart. So liquid, gas, solids, you never break those apart. Ionic compounds, you can only break apart if they're aqueous. And for acid, you can only break it apart if it's strong. So with that being said, starting with the acid, I look to see if it's a strong acid. Is it on this list? There it is, H2SO4. That means I can break it apart. And when I ionize it or break it apart, it's going to be 2H plus. Remember that subscript becomes a coefficient, and the charge on the H is going to be plus. And then SO4 2 minus. Notice I didn't put a 2 here because that subscript went just for the hydrogen. If there was a coefficient of 2 in front of the entire molecule, of course I would have to put a coefficient of 2 in front of the sulfate. Next we're going to do the barium hydroxide because that's aqueous as well. It's an ionic compound that's aqueous, so we break that apart. And again, I use the subscript here as my coefficient because I have 2 hydroxides. All right, on the water side, on the product side, water is a liquid, so we don't break that apart. And I'm just going to write water as 2H2O. And the barium sulfate, this ionic compound is not aqueous, so I can't break that apart. All right, so with that being said, now I'm looking at this. I can't cross out anything to make my net ionic equation. So the net ionic equation and complete ionic equation are the same thing. There's nothing I can cross out. Now on the exam, I'm going to be careful to make sure that the salt that you have is aqueous. I'll try and make sure you have an aqueous salt instead of a solid salt. It'll make it a little bit more easier. But the overall process is the same. So let's just back up. Key thing to remember. For acids, you only break them apart if they're strong. If they're on this list, you can ionize them. For the bases and the salts, so any ionic compound has a metal and a non-metal part. Look on the solubility chart. And never break apart water because it's a liquid. All right, let's look at our last example now. This is acetic acid. So acetic acid is one of the Cu group acids. And the thing to remember about acetic acid, the hydrogen, acidic hydrogen, is written at the end, not in the front. So when we're doing our switching, we have acetate, which by the way is one of your polyatomics, CH3COO minus, that's acetate. It's one of your polyatomics. That portion will go with the metal. So CH3COO will go with SRO. That's over here. Strontium. And that will make your ionic compound. And then the hydrogen at the end, just take off the hydrogen at the end and link that to the hydroxide on the other side of the base. Okay, so so what you do is you just take the hydrogen off at the end, make it react with OH to form water, and then everything else that's left, the CH3COO, that goes with the SR. All right, now that we've switched them, what we have to do here, and that's what we've written on this side, is figure out the chemical formula of the ionic compound. Water should already be taken care of, HOH or H2O. Strontium has a 2+ charge because it's in group 2, and acetic acid, has a -1 charge. You would just look on the chart. So looking at this, we need 2 acetates in order to get the charts to balance. So the correct formula will be SrCH3COO in parentheses 2. Remember, when you have more than one polyatomic, you put it in parentheses and put a 2 outside. All right, now we're going to balance this. So on this side, we have 1 acetate, 1 hydrogen, 1 strontium, and 2 hydroxides. Here we have 2 acetates because of that subscript outside. 1 hydrogen, 1 hydroxide. Remember, water has an H and an OH part. And then 1 strontium. I look at this and I say, oh, my acetates aren't balanced. So to balance that, I put a 2 in front of the acetic acid. That changes the number of acetates to 2 and the number of acetic hydrogens to 2. Now I look at the H and OH, they're not balanced. So I need a coefficient of 2 in front of water to balance them. Okay, now we're going to go on to our complete ionic equation, CIE. For acids, actually first we're going to go ahead and put our symbols in. So acids are always aqueous, but that means nothing for the acid. That means absolutely nothing. To figure it, you can break it into ions or ionize it, you have to look at the list. If it's on the strong list, you ionize it. So all the acids are always aqueous, but it means nothing to them. For the base and the ionic compound, we look on this chart here, and strontium hydroxide is aqueous, and so is strontium acetate. And water is always a liquid. So water is always a liquid, acids are always aqueous, but that means nothing. And the base and the salt, they're ionic compounds, so you figure that out from this list. Now that you have that done, we're going to start with the acid, figure if we break it apart or not. So to figure that out, we don't look at aqueous. Remember, that means nothing for an acid. We look here on the list. Is acetic acid one of our strong acids? It's not. In fact, acetic acid is vinegar. It's a weak acid, so it's not on this list. So that means, can I break it apart? Nope. So I'm going to write it just as is. And you can put the symbols, the phases in or not. All right, let's go to strontium hydroxide. That is a strong, not a strong base, that's an aqueous ionic compound. So for ionic compounds, the aqueous matters. It's aqueous, we can break it apart. And notice I put the 2 for the coefficient of hydroxide. The subscript that was outside the parentheses becomes my coefficient there. Water, can we break it apart? Absolutely not. It's a liquid. We never break apart water. So water always comes down as H2O. And then here, this is aqueous as well. This ionic compound is aqueous. So I split that apart into ions. And once again, that subscript for the acetate becomes its coefficient. Okay, so now that I'm looking at this, I can now go on to my net ionic equation by crossing out things that are ions on both sides. This is not an ion on the reactant side, so I'm not crossing that out. Sr2 plus is an ion on both sides, so I cross that out. And the hydroxide is an ion on the reactant side, but on the product side it's a part of water, so I can't cross that out either. So what I have left is my acid, which again is aqueous. Aqueous acids mean, aqueous means nothing. Okay, and then H2O liquid, and then this is also the acetate ion. Okay, so that's it. So key things to remember. For the most part, you're doing the same thing that you did before with precipitate reactions. For the ionic compound, the base and the salt, look on the chart. The water, never split it. The acid, only split it if it's on this list. All right, I hope you found that helpful. And with that, good luck with studying. Have a quality day.